So let's take a question. Two particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight line towards an intersection O. At the moment t equal to 0, the particles were located at distance L1 and L2 from the point O. How soon the distance between the particles will be the smallest, and what is it equal to? So as I've already drawn here, so these are two particles 1 and 2 with velocities v1 and v2 at distances L1 and L2 from this point O, and they are moving in mutually perpendicular straight lines. So the distance between these particles at after time t will be equal to how much? Under root of this thing. If I say this is the distance and this will be the square of the distance, I'm saying that these distance between the two particles after time t. It's obvious that in time t this would have traveled a distance v1t, this would have traveled a distance v2t. So this initial length is L2, this is v2t, so this is L2 minus v2t. Similarly, this will be L1 minus v1t. So L1 minus v1t whole square plus L2 minus v2t whole square is equal to d square, where d is the distance between the particles. This will be d. Now, how soon the distance between the particles will be the smallest? So it's obvious we have to just integrate this thing with respect to t. Now, if we expand this, L1 square plus v1 square t square minus 2 v1 L1 t v2 t. This is the, I'm considering the square of the distance because it's a little bit more simple to handle. Now, how soon the distance will be between the particles be the smallest? You just have to differentiate this with respect to time and equate that equal to 0. So if you do that, what do you get? All the constants will get evaluated to 0. So this is 0. This is v1 square into 2t minus 2 v1 L1 plus 0 v2 square into 2t minus 2 L2 v2. This will be the differentiated. Equate this to 0. So what do I get? v1 square 2t plus v2 square 2t equal to 2 v1 L1 plus 2 v2 L2. So what is t? Sorry, v1 L1 v2 L2 divided by v1 square plus v2 square. Now just substitute this value of t in this expression and you will get the minimum value of the value of the distance when the particles are at their closest. Now there is one more thing that we need to understand out here, and that is that we have just use the concept of minima or maxima, right? So we are interested only in finding out the minimum value when the distance would be the minimum. So we have just differentiated it and equated that to 0. Now that can be the maxima as well. Now how do we know that that is not the maxima and that is the minima? The value of t that we've got here is the value for the minima and not the maxima. How do we know that? Because the conditions for both minima and maximum are the same, right? You just have to differentiate the equation and equate that to 0. Now suppose if I do this, suppose if I consider this, and suppose if I further differentiate this with respect to time, what do I get? D square by dt square will be equal to, in fact this is d square, what do I get? I'm differentiating this with respect to time. This will be equal to 2v1 square plus 2v2 square. So in other words, v1 and v2, I have squared these two things, and this is always a positive thing. So when the rate of change of a certain thing is positive, and in fact the rate of, I'm considering the rate of change of not a quantity but the rate of change of a certain thing, because this is d by dt of a change of rate of change of a certain thing. So this is the change, the rate at which d square by dt is changing, right? I know that this is, as far as this is concerned, this is just the rate of change of d square with respect to d square, because I have a relationship between of d square with respect to t. Now there is a rate at which d square changes with respect to t. Now there is a rate at which this changes with respect to time. So it's rate of change, rate of change of rate of change. So it's like saying that velocity is equal to dx by dt, but then acceleration is equal to dv by dt, which is something that is we have already seen, and velocity itself is equal to dx by dt. So acceleration we can say is equal to d square x by dt square. So what is this? Rate of change of velocity. So what is acceleration? Rate of change of velocity, and velocity itself is rate of change of displacement. So this means rate of change of displacement. So this is rate of change of displacement, right? Because you are differentiating x with respect to time twice, right? Similarly here you are differentiating this with respect to time twice, and what you get here is a positive thing. So whenever you get something like this, that something is positive, you can always say that it is the minima and not the maxima. It means that the slope has changed, and that change in the slope is positive. So the slope is changing from a negative value to a positive value, and that happens only when you're talking about the minima, right? So since this is positive, you can say that we are talking about the minima and not the maxima. So this is one thing. So let's take another question. From a point located on the highway, one has to get to a point B at the earliest. Point B is on the field. Speed on the highway is n times greater than that on the field. At what distance from D one must turn off the field? This is 90-degree angle. Okay, this distance is L. So the question that they are asking is, what should this distance be when either the car or the person should turn off the highway and enter the field and go straight towards point B, and for that what should be the value of x for the time to reach from here to here is the minimum. So the time to reach from here to here is the time to reach from here to here plus the time to reach from here to here. Now let's calculate the distance from here to here. Say the initial distance is say di between A and D. So initially the person who's driving a car or any other vehicle, it's say at point A and this is the point D, and say is the initial distance is say di. I don't know, forget what is D. This is di. So this will be di minus x. Divided by speed on the highway. Say Vh is the speed on the highway and Vf will be the field speed on the field. So this is x, this is di, this is di minus x, this is x, this is being given to us as L. So this will be under root of x square plus L square. This will be equal to under root of x square plus L square divided by Vf. Now Vh by Vf has been given to us is equal to n. Vh by Vf is n. Vh is the speed on the highway, Vf is the speed on the field. So this total time we can say is equal to di minus x n Vf right. So we've got t as a function of x, right? So if x has got a certain value and you want to find out what is the time that this person takes to reach from A to B, this will be given by this much. Now the question is, what should be the value of x for this time to be the minimum? So again here we have this concept of minima, right? We just have to differentiate this with respect to x and put that equal to 0. Let us do that. dt by dx will be equal to, if we differentiate this whole thing with respect to x, what do we get? Minus Vf plus 1 by Vf 1 by 2. This will be equal to x minus 1 by n into 1 by Vf. So now you equate this to 0, and if you do that you will get the value of x equal to L square by n square minus 1. X will be equal to L by under root n minus 1. You'll get this. So we know that dt by dx we just saw is equal to this, right? Now let's calculate d squared t by dx square. because you have differentiating this. So we all know that this will be constant, so we don't have to worry about this. This will get evaluated to 0. As far as this particular component is concerned, it's got two things. One is x, the other is x square plus L square to the power minus 1 by 2. So we'll differentiate this accordingly and we'll get this, right? So as we all know, first we have to take x and then differentiate this. The next time we have to take this as it is and then differentiate x. So once we have done that, if we simplify this further, what we'll get is this will be x square minus divided by vf x square plus L square, x square plus L square, because this is L square plus x square plus L square to the power 3 by 2, which is equal to under root of x square plus L square into x square plus L square, plus 1 by vf x square plus L square. So 1 by vf you can take out as common, under root of x square plus L square. What you will get is 1 minus x square by x square plus L square. Right? 1 minus x square plus L square. This is equal to 1 by vf into x square plus L square into L square by x square plus L square. This is a positive quantity. Why? Because all the things are positive here. L is positive, x is positive, vf is a positive number, we know that. So all the things are positive here. So this is a positive quantity. So as I explained in the previous video, d square t by dx square is basically a positive thing. So it means that the slope is changing in from negative to a positive value. So it's the minimum that we are talking about. Okay? So it will only have a minimum because the slope is changing from, slope is always positive. So if at any point of time we have this equal to 0, that can only be the condition for a minimum, right? So as we saw, x square will be equal to L square divided by n square minus 1, or x is equal to L divided by, this is the value of x for which the t time total is the minimum.